Hello, I am Bisser Marinkov, an associate of the History Museum of Primorsko, and I will be introducing the topic of LiDARs as well as sharing some of my personal experience and how this technology helps in archaeology, digital reconstruction, and preservation. LiDARs work by emitting rays of light that then bounce off of objects and return back to the emitter. By calculating the travel time of the rays and the GPS location of the LiDAR, it creates an accurate 3D model of the object or area.
Now, to explain the image you're seeing on screen. The raw data collected by LiDAR forms what is called a point cloud, which is comprised of millions of individual points in a three-dimensional space. These points are later processed into a detailed 3D model or terrain maps.
Here, we can generally split it into two categories: small portable LiDARs, such as the ones integrated into tablets, or bigger, more powerful ones attached to planes to map out an entire area of the land. First, let's begin by talking about the use cases, pros and cons of using small portable LiDARs. They're used for either small objects or small areas of the land, such as sectors of an archaeological site. Here are some examples of scanned objects. And now, for an example of an archaeological site. These scans help people working with 3D models, such as myself, to recreate objects and restore them. And now, let's take a look at more powerful LiDARs and their uses. They are mounted on aircraft or drone, fly over an area, scan the land, and make a 3D model, and showing interesting features of the landscape, such as straight lines and other features which might indicate human activity, and thus help archaeologists explore the land and make new discoveries.
An additional component used by such LiDARs is an IMU, which stands for Inertial Measurement Unit, and works as follows. It does not measure distance directly. Instead, it determines the exact position and orientation of the LiDAR during the scan. This allows the collected distance measurements to be placed accurately in 3D space. This is what the final result of an aerial scan would look like after it has been run through the proper software. The initial model is tidied up, removing elements like trees and vegetation, thus presenting a clearer image of the analyzed landscape.
With that being said, let's explore some problems of the technology. Since LiDARs emit rays of light, if we are to try to scan something that reflects light or lets it pass through, we run into some problems. For example, as you can see, this scan has multiple holes due to the fact that light passes through the glass. That's used for the restoration of the item. But the old Roman glass has enough impurities to allow the scan to work. Another problem we can encounter is specular reflection from shiny objects, and as such, we cannot get a proper texture of the item or the 3D model might not even be made correctly. And lastly, dense foliage may cause issues and obscure important information. To sum up, LiDARs use three main components: light rays, which bounce off of objects and return to the emitter, the built-in GPS allowing it to calculate the distance and size of the objects, and lastly, photographic data, taken during the scan, is used to recreate the textures of the object. Having concluded my part, I thank you for your attention and send you my best regards.